Systems of inequalities. This is actually not in your SM3 book. You supposedly learned these and learned how to do this in SM1, but we're going to review it to go on to the next thing. So, first of all, in your notes, you have fill in the blank. The following is a system of linear inequalities in two variables. Okay, so unlike equations, instead of equal signs, we have inequality signs. A solution of a system of linear inequalities is an ordered pair that is the solution of both inequalities in the system. Okay, so if you need to pause and write that in your notes, great, go ahead and do that. Okay, so what I want to look at here is whether or not this coordinate, 3, -1, is a solution to this system. So what I need to do, just like with equations, I'm going to plug it in and see if I get true statements. So x is 3, y is -1, so 3 plus -1, is it less than or greater than 6? Well, this is 2, and 2 is less than 6, so this is true. Okay, we also need to plug it into this inequality. So 2 times 3 minus a -1, is that larger than 4? Well, since this is 6 plus 1, 7 is larger than 4, so yes. So yes, this is a solution to this system. Okay, so let's try this again, but let's try it with a different coordinate. Okay, this is -3, +1. So when I put this in the top inequality, I have -3 plus 1 is less than or equal to 6. Is this true? Well, yeah, because this is -2, less than or equal to 6. So yes, that's true. Okay, now let's plug it into the bottom one. We've got 2 times -3 minus 1, is that bigger than 4? Well, 2 times -3 is -6, minus 1 is actually -7, and -7 is not bigger than 4. So since it didn't work for both of them, the answer is no, this is not a solution to this system. It was for just one of them, but not for the system. All right, so I put this in your notes, but I'll go over it real quick. So first of all, when we are graphing systems of inequalities, we need to treat the inequalities at first like equations, and those are going to be our boundary lines. If it's a less than or a greater than sign, then the line is dotted or dashed. If it is less than or equal to or greater than or equal to, then we have a solid line that we use for the boundary line. Okay, that's what I think of it like. There's a line under here, so it's a solid line. Okay, we pick a point not on the line. If that point, and then we take that point, we plug it into the inequality, and if it makes the inequality true, then we shade the side that that point is on. If it's not, then we shade the side that it's not on. Okay, and then you can use different colored pencils or different angled lines to shade so you can see where they overlap. So let me show you. So first of all, what I've got here is, well, I've got a system of inequalities, and I'm going to look at my boundary line. So all I'm doing is switching this to an equation. So I'm just turning this into an equal sign. So this is -3x minus 1. Okay? And hopefully you remember that to graph a line, we can put it into slope-intercept form. B is my y-intercept, and m is my slope. Okay, so I'm going to start with my y-intercept, that's -1. And my slope is -3/1. So I'm going to go down 3 and to the right 1. So 1, 2, 3, 1, 2, 3, and over 1. And my line is going to be solid since I have a greater than or equal to. Ooh, that's a yucky line. Anyway. And now what I'm going to do is I'm going to test a point. There's a couple things we can do here actually. We can test a point, I think, that's not on the line. And I'm going to test 0, 0. And I'm going to see if that's true. If 0, 0 is part of my solution. And if it is, I'm going to shade that side. If it isn't true, I'm going to shade the opposite side. Okay, so I'm going to plug that in. So I have 0 is less than or equal to -3 times 0 is 0 minus 1. And this is 0 bigger than or equal to -1? Yes. So this side gets shaded. It includes the 0, 0. Okay, so let's look at this next one. Okay, my boundary line is y equals x plus 2. That's my boundary line. So I go to 2, my y-intercept, and my slope is 1/1. So it comes up like this. And my line is going to be dotted because I don't have a line underneath here. So I can just kind of make this a dotted line. Okay, and again, it doesn't go through 0, 0, so I'm going to test 0, 0. So I'll test that one. So I have 0 is less than 0 plus 2. Is 0 less than 2? Yes. So I'm going to shade this side. And what I'm looking for then is where it overlaps, which is this little wedge right here. Okay? Another thing you can do is if you have an inequality with the y by itself on the left, you can look at this sign and you know where to shade. So in this case, y is bigger than this. So I come over to my line and I shade above the line. Okay, so here's the line, here's my y-intercept, I shade above. Okay, here it's below. Y is less than x plus 2. So I look at my y-intercept again and I shade underneath, and that will give me that same wedge right there. All right, we will go on in the next video.